We are going to create the infrastructure by writing the code. What I meant by infrastructure? Infrastructure is nothing but cloud resources. If I says cloud infrastructure, cloud resources, if I says cloud infrastructure, cloud resources, if I says cloud infrastructure. What is cloud resources? Virtual machine, storage account, virtual network, DB, of course, AKS, Azure Kubernetes Services. These are my infrastructure. I will call it, these are my cloud infrastructure. This infrastructure we are going to create by writing the code. So that is called Terraform. And language used here to write the code will be HCL HashiCorp language. Language used to write the code will be a HashiCorp, or we have JSON as well, JavaScript object notation. We have JSON as well, JavaScript object notation, but majorly we are going to use HCL HashiCorp language. Then what we need to understand from here, we have another ISC tool. These inbuilt ISC tool are only for cloud infrastructure. Those are nothing but our is ARM templates. We have templates. These templates are written in JSON. So these ARM templates are very specific to cloud only, but we cannot be used on multi-cloud deployment. With the help of Terraform, we can do multi-cloud deployment, multi-cloud provisioning. We can edit, we can modify, we can build, we can delete. What we can delete? We can delete the infrastructure or resources created by us. That is what we need to understand. Then we need to understand another thing here, that is called providers. So what I meant by provider basically, provider will provide plugins or API interaction to interact with Terraform, and the resource or place where we want to create, configure our resources. Our provider are Azure. Our provider are Azure here. Our provider are Azure here. Which provider version we are using? We are using provider version equal to 4.37.0. This is my Azure provider version. And what Terraform version we are using? What is the latest version of Terraform? Latest version of Terraform is 1.13.2, but yesterday we configure 1.12.2. This is the Terraform version. Don't misunderstand. Azure provider version with the Terraform. Terraform version is different. Azure provider version is different. So this is what we need to understand. And another thing what we understood here, so if I go to the terraform.io official website of Terraform, if I'll go to the terraform.io official website of Terraform, in official website of Terraform you will get entire documentation of how to install Terraform on where? On a VM, of course, virtual machine. That virtual machine can be from a RHEL, that can be from Ubuntu, basically, if I say Debian family, or that can be from Debian family or any family. So basically, we can create a Terraform environment in our desktop as well. Yesterday we understood by downloading the binaries. Please download the binary, and for that binary you have to configure the environment variable. Apart from this, what do you need to understand here? This you need to configure, these binaries you need to configure. After configuring binaries here, you will be able to create a lab environment. What about environment here? If I'm talking about lab environment here, in lab environment section, what we need to understand? We need to create one file, and that file will have extension called .tf. Under this file, there will be two blocks. First one is provider block. Of course, plugins where you are creating resources, those provider block. First block will be your provider block, and second block you need to define is the resource block. You need to define second block equal to, that will be your resource block. Provider block, resource block. After defining a resource block, provider block, of course, you can create this block inside file.tf. TF is extension for Terraform. Or you can create separate file for resource block, and you can create separate file for a provider block. You can create separate file for provider block. You can create separate file for resource block. You are a boss here. You can create this. Understood? So this is what till here we understood here. Till here we understood. So now what we are doing here, what we are doing here, so this is what we need to understand here. So we need to understand here, this is what I did, Sharad. What I did, this is what I did, right? Okay. See, follow me, please. Understand? I said many times, right? Please follow me. Understand? So the way I am going, you follow me. Then what I am saying here, so this is what you need to understand. And please take a screenshot of this. Please take a screenshot of this. You people need to take a screenshot of this. Just a second, please. Not now. Of course, you won't be able to create. Right? Okay. Yeah, we're doing fine. I want you to go little loud. I want this to be little loud. Yes. Now let's understand here. Today I'm going to what I'm going to do. I'm going to give you a workflow. If I say the workflow for right, workflow for entire things, whatever we did here, and please listen carefully. Right here, I will prefer you not to type many questions here. Don't type any question. Listen me, please. These things are already covered. If you go again and again there, so it won't be nice. What I'm saying. Please listen me carefully. I don't want you people to type here. Okay. So if you have some question, you can write in your notebook. Okay. Immediately after the session, you can ask me. Listen carefully here. What I am saying, as I said, we are learning a cloud, we are learning a DevOps, and we are learning a Linux. This was our topic, and this is going to be our topic further as well. But why we needed cloud here? Because cloud is providing on-demand services. Cloud is providing on-demand services. How many services altogether cloud is providing? 300 plus services. So those services are distributed into different domains. What example of those services? Computer resources, storage, database services, containers, networking, those services. So then, but why we need services here? As I said, why we need services here? I have what I have. Because I want to automate, if I want to automate my software development life cycle, I need DevOps. If I need to automate my software development life cycle, I need a DevOps. So by using the DevOps, I'm going to automate my software development life cycle. I'm going to automate my SDLC. As I will automate my SDLC here, finally what I will get as an end user, I will get end application accessible to me. End application accessible to me. But to then in this SDLC, if I says DevOps is nothing but I have to use a series of tool. In DevOps, what is that? DevOps is nothing but a method, a culture, a tradition. In this tradition, in this culture, we have to follow series of tools. We need to use series of tools. By using series of tool, we will automate our software development life cycle and we will deliver application to the end user, and that end user will be able to access our application. But to run this entire infrastructure or run this entire, what we have to do, run this entire tool or create an environment for DevOps here, what we need? We need a server. And from where we will take the server? We will take server from the cloud, and that is called virtual machine as of now. If you are doing IIS, if you are doing infrastructure as a service, if you are creating a server on infrastructure as a services, then we need infrastructure as a services, basically server, or I'll say virtual machine. On the top of virtual machine, we can install the tool, individual tool, and then we can deliver application to the end user. Or if I don't want to use much here, I want to use basically infra services provided by cloud, I will go to the PaaS, platform as a services. I said we have app service. In that app services, what we have? By default, they will have infrastructure, inbuilt infrastructure. Basically, PaaS, SaaS is nothing but till what level you are taking help from cloud to automate your software development life cycle. Till what level you are taking help from them. Then what I am saying, after this, what we need, we are able to deploy the application here. So this we are going to, this is one of the service provided by cloud. What I am saying, to deliver application to the end user, to automate our software development life cycle, we need DevOps. But we need cloud as well, because cloud will provide us underlying infrastructure, services, or security as well to deliver our application in a secure way. But I need this. And what about Linux? So as I said, I'm talking about server, I'm talking about interface. That interface will be provided either by Windows, either majorly by Linux. That's why we need. But let's understand the cycle. So I want to know about service. So what is my main target here? Then we started with the cloud. What we started? We started with the cloud. Now what cloud did us? Cloud provided us services. How many services? Cloud provided us 300 plus services. But as cloud providing us 300 plus services here, we need to use certain services. To use the services, we need to define our identity. That was under Entra ID. What we have? We have a subscription. What we have? We have a subscription. Subscription. What subscription will do? Subscription will enable us to use what? Use the services of cloud. What subscription will enable us? Subscription will enable us to use the services, because unique identity will be, unique ID will be generated, and unique ID will be generated under this ID. Under this ID, you are allowed to use the services. But how you will use the services? You will use the services within the resource group. What you will use? You will use the services within the resource group. What do you have? You have a resource group. Grouping together all your resources in one certain group. You have a resource group. Within the resource group, what you are going to do? You are going to create the services. You have a resource group here. You are going to create the services here. All services will fall under this. But there will be many users here. There will be many groups here. So we need to manage users, we need to manage the groups, we need to manage the application here. Those where we will manage, please remember, under Entra ID there will be one tenant. Under Entra ID there will be a tenant. And after defining this tenant, why we will have a tenant, and this tenant will be allocated to, and this tenant can be allocated to subscription. Automatically it will be allocated to subscription, and there can be more than one subscription under one tenant. There can be more than one subscription under one tenant. Now what is the responsibility of tenant? He will manage the users, he will manage the groups, right? He will manage the users, he will manage the groups, and apart from this, he will manage the users, he will manage the groups, he will manage the application, he will help us to manage the devices here. He will help us to manage the users. He will be helping us, or he is helping us to manage the applications or devices here. All these things will be managed here. People will ask you, what is mean by subscription and tenant? So your answer has to be ready. So then after doing this, we have subscription. Under this subscription, we are allowed to create the services. And these services will be created by whom? These services will be created by this user under one certain resource group. And this sort of services, whatever services he required for his end environment. So this is what we need to understand. Of course, and if I'm saying very specific here, of course, user login will be, log information of user will be, his sign-in log will be. So what will be? His sign-in log will be. And apart from this, this user can be a part of a multiple group. This user can be a part of single groups. In groups, user can be a part, application can be a part, devices can be a part, even groups can be a part of groups here, right? and we can enable MFA, multi-factor authentication for what we can do. We can enable or disable MFA, multi-factor authentication for single user or multiple user. Or what option Azure Entra ID is giving us? He is giving us one option here. We are allowed to create multi-user at once. If I want to create bulk users, I am allowed to create the bulk users, but bulk groups are not allowed to create. Please take a note. This is what. But if I am creating another thing here, I am allowed to create external user as well. This external user will be only for B2B, business to business use here. Suppose they need access for certain application. For that access, we are going to create one external user, and for that external user, we can set up MFA as well, multi-factor authentication as well. So this is what we understood here. Then we jumped into another service. Under services, what we understood. If I says under services, where we jumped into, under services, we jumped into the compute service. Under service, where we jumped into, under services, we jumped into the compute. What I meant by compute, please understand, compute is related with the processing power. And that processing power is provided by whom? Processor. But don't understand, I am talking about compute power of system. System compute power will be provided by RAM, will be provided by SSD, and will be provided by, of course, altogether, if I say it's a CPU or majorly will be a processor. I am talking about compute power, compute resources. Under this, what we created? We created a virtual machine. What we created? We created a virtual machine. We created one server. What we did? We created one server here, virtual machine. So now this virtual machine will enable us to configure server or enable us application, so we can run end application here. Under what are the component of virtual machine here? Component of virtual machine comes what? We have to define. What property we have to define under this? We have to define one certain region where we want to host this virtual machine. Under region, you can replicate this machine into multiple zone. You are allowed to replicate this machine into multiple zone here. So availability of your machine will be in more than one place. But costing will be twice, thrice. Costing will be because you are going to use hardware component of that region. Right? Then what we need to consider? We need to consider the image. Image is nothing but template of operating system. Windows server, Windows template, Linux server, Linux template. For image, what you can do? You can go to the marketplace also. What you can do? You can go to the marketplace also. From the marketplace, you can take pre-customized image and you can use those image for your end task. You can use pre-customized image and you can do. Or otherwise, what is another scenario here? For this virtual machine, for the same virtual machine, you can create an image, and that image you can store within the storage gallery of what? Image. Now here something like this. What is the advantage? What is advantage of creating your own customized image? Advantage of using your own customized image is nothing but you can use what? You can use that for storing. Suppose I installed, yesterday I installed Docker, right? Docker into my server. So as I install Docker into my server here, what I can do, I suppose 10 people, 20 people need those Docker server. What you will do, you will create image from that server and you will share that image to all the person here. So they will get that image with the Docker server pre-configured on that. Everyone no need to spend more time on this. Linux server, Linux template, Linux image, Windows server, Windows server, Windows template, Windows. Now here another thing here under this, what we need to understand, these things we need to understand. But as I said, another thing, whenever I am talking about by default, what will be there? If I am talking about BM, we need to consider regions, which region we are hosting this, right? Whenever you are hosting something into a region, you need to think about latency. At the same time, you need to think about costing as well. And you need to think about a resource quota as well. What is allocation here? Is there whatever the server you are taking? Suppose I am taking B2S. I'm going to the series called B2S series. Under this series, how many server we have here? So suppose I need 15 server here under B2S categories. You need to check whether you have enough resources here under B2S or not. If not, then you can go to another series, or then you can go to another location. Again, I'm saying please consider latency, lag, amount of time to create the resources. And think about scaling as well, scalability as well. If I'm saying about scaling, we need to think about scaling. If you don't have available resources left here, if you don't have available resources left here, then what you need to do? Then you need to go, what you need to do here? Then you need to check this. Then you need to change the series from here. So this is what we need to understand. You can go here. Then apart from this, then next thing here, what we need to understand, please, we need to understand about, if I'm saying about a machine here, machine will have a different size. What will have? Machine will have a different size, and this size of any server or virtual machine will depend upon compute optimized, high processing power, storage optimized, high storage, high performance one, high storage, high compute power. It depends upon server to server, depend upon location to location. Costing, in costing, major factor in costing, if I'm saying costing about the server, major factor will be a demand. If there is more demand here, in that region, pricing will be high. So pricing is not same in all the region, as we know. And if we want to know thorough calculation or end-to-end information about pricing, we need to go to the pricing calculator. And from the pricing calculator, we will get fair idea of what are the resources, how it's costing, what it's costing to us, how much it's costing to us. So another factor here, while creating a virtual machine, we need to consider is a disk. Another factor, while creating a machine, we need to think about a disk here. So what we need to think? We need to think about disk. If I'm talking about disk here, disk is divided into three categories: premium SSD, standard SSD, standard HDD. By default will be premium SSD. And premium SSD will be expensive among all. So you should avoid, you should choose the right disk for your right task. Don't get overwhelmed by resources. Then if I'm talking about Windows server, Linux server will vary from, Linux server disk size will vary from 10 GB to 2 terabyte. And in Windows server, it will vary from 127 gig to 2 terabyte. So it will vary from here to here. So what we are going to get, this is what. Now another thing here, while configuring, so now I configured a VM. I used one service called, I am talking about entire service. Under entire services, I am talking about VM. If I am talking about this VM here, one thing we need to understand here is how you are going to expose this VM to the end user. To expose this VM to the end user, we need to consider certain factor. What I am saying, there is one external user who is sitting outside the network here. To expose this virtual machine to the external user, we need to think. What we need to think? We need to think secure way. So what we have SSH here. What we can do? SSH. SSH will enable secure communication from where? SSH will enable secure and encrypted communication from your host machine to your client server. So you can do SSH as well. Or another here, you can expose IP or port number to the external user. You can expose port number or IP to the external user if you are accessing application running inside the server. Or how you can expose your virtual machine? You can expose your virtual machine only through the IP, but public IP. Because reach of public IP is on a World Wide Web. On a World Wide Web, on internet, anywhere on the internet you can expose. But problem here is we should not expose machine through public IP because it's very unsecure. So what we have? We have another option to explore or expose our machine. That can be our Bastion host. We can use Bastion host, and by using Bastion host we can expose our machine in a secure way. Then I showed you another way here. We can create a jump server as well. We can create a BM jump server by configuring BM jump server, but this jump server was for only Windows. You can use this for a window environment, right? Any question till here? So this is what we need to understand, right? So this is what we need to understand. There are many information here. Understand? It takes a lot of energy to talk continuously, right? See, this is what we need to understand. Like this, your knowledge has to be. The way I am explaining, your explanation has to be like this, right? Whatever this, and any question here? Mr. Shavan, any question? Shiri, Sharad, right? Priyanka? Yes. Are you people listening, or I'm just wasting my time here? Don't worry, Riyaz. Listen me. I said follow me, right? Follow me. Understand? Follow me, please. Understand? I'm going there. I'll give you entire till Terraform. I'll reach. Right? Sir, please explain one more time. No, 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 not possible. You need to go to the this. You need to go to this. Not possible to explain the same thing again. How I can explain Anupam same thing? Right? Understand the flow. If you have not practiced, you will not be able to understand. Don't put a blame on me here. If you are not practicing, you will not be able to understand what I am saying here. If you are following day to day, you will understand entire structure, whatever I am saying. Okay? Not possible to explain again, same and same. For half hour, I said this, again I am explaining this. So here, now what we need to understand, we understood about the virtual machine. Why we need a server? See, please understand the flow. Where we need this? We need this. We need this here, then DevOps will come. So this we need. So as we need this here, then what we need to do? We need these things here. Then what I am saying, these things we need to understand here. Then what about, so we need to set up secure communication. So I don't want to, so what is my thing here? I need this server to expose to the external user. What I need this server to be exposed to the external user or to the external world who is sitting somewhere on www, World Wide Web. If some user is setting somewhere outside the World Wide Web, so what I can do for this, I need to set up networking. What I have to do, I have to set up the networking, because networking will enable secure communication between a external user, the user who is sitting outside the web, not outside the network, right? And what we have here, because of this reason, within the cloud, what we have a virtual network. Within the cloud, what we have one outer layer. This outer layer is nothing but, let me take example. In cloud is divided into region. Cloud is divided into region, and within the region, what I have, if I says region, within the region we have a virtual network. If I says region is divided into virtual network, and virtual network is very specific to region. Virtual network is very, very specific to region. Cloud is divided into region is divided into virtual network. There can be more than one virtual network in one region, and the virtual network is region specific. And within the virtual network, if I says within the virtual network, there will be a public and a private subnets. There will be a subnets here, and subnets are divided into private subnet plus public subnet. Subnets are divided into private subnets and public subnet. Private subnets and public subnet. And within the public and private subnet, what we will have? The server. Just now what I gave story. I gave you people a story. Story of what? Story of virtual machine. This will be created where? Inside here. So this is created. So now these things will be created where? These things is created here. Virtual machine. This video will be very, very important. This video will be very, very important, very highly rated. Each and everything I am covering in one session. So what I am saying, networking we need. Why? Because we need to expose this virtual machine to the external world. In one region, we will have a virtual network. Virtual network is very specific to region. And within the region, we can have more than one virtual network. How big your network has to be, it will be decided by classless inter-domain routing. We will have a subnet mask vary from 1 to 32. According to that, what we will do, according to that, we will decide how much big our virtual network can be, how big our virtual network can be, and subnet will get share from virtual network. Subnet will get share from virtual network. How big your virtual network is depend upon number of IP. Virtual network is nothing but a range of IP. Within region we have virtual network here. Virtual network you can think like basically your private network, or very specific private network for your end application. So now here if I'm talking about private subnet, here private subnet will have a private IP. Private IP, and reach of private IP is only within the network here. What I said, reach of private IP is only within the network. Outside the network, through IP we cannot interact. Or if I says public IP, reach of public IP is directly to a World Wide Web. But why we need IP? We need IP. IP will enable our communication to the web, internet, external world. So this is what we need to understand. What we have here, we have internet gateway. What we have internet gateway here. Please remember, in Azure IGW, internet gateway is internally inbuilt. We don't have external internet gateway here. Another thing here, we have a NACL, NACL, network access control list, or ACL. ACL also we have inbuilt here. We don't have any NACL here. In our network access control list, we don't have here. So what we have here, we understood that we have NSG. Apart from these things, what we have NSG, network security group. This network security group will enable our communication, where this is a protection on subnet level. It will protect us on a subnet level. What this NSG will do, network security group will enable our request, will allow us access on a 5 tuple: source IP, source port, destination IP, destination port, plus protocol. And on the basis of priority. On the basis of priority. Then we have another thing here. I think you people need to remember, very, very important component, NIC. Network interface card. Basically, network interface card will be attached, not here. It will not be attached here. It will be attached to your virtual machine. NIC, network interface card. This network interface card will enable what? This network, with the help of network interface card, your machine will be connected to the network. Then only it can communicate to the external world. Of course, there will be a route table. And another thing about network interface card is, whatever the IPs, public IP and NSG configuration you are getting, this configuration will be provided by network interface card. You can allocate, you can deallocate IPs from here. Then I am saying, second thing we need to understand is a route table. Route table will route your request from gateway or from network to your subnet, because there will be more than one subnet within the network. So route table will route your request. If I says, what route table will do? Route table will route your request from this to here. Then how big your network is? CIDR is a factor. Classless inter-domain routing is a factor here. Because of this factor, because this factor will decide our routing method. This is what we need to understand from here. Then apart from this, we need to understand a certain thing here. We need to understand what is Bastion host here. Basically, Bastion host will provide private IP connectivity. Through private IP connectivity, what we have here? We have a Bastion subnet. What this Bastion subnet will do? This Bastion subnet will enable communication. Right? This Bastion subnet will talk to the private IP. Right? Communication, how the communication is. Bastion subnet. We have a Bastion subnet here. Through the Bastion subnet, we have a private IP. And through the private IP, we can communicate. It will set up secure communication through this. Secure communication through this. Right? This revision I am giving you people complimentary. Understand? This is not a promised thing. I want you people to revise what this thing is. Don't take this for granted. Understand? I am giving you a revision of entire thing. Please notice this. What I am saying, Bastion host, Bastion subnet, private IP, and of course here will be your machine VM. So how Bastion will set up the communication? Bastion will set up the communication like this. You are able to connect to your machine very securely. This will help you to connect your machine very securely here through a Bastion. Then we have another thing called DDoS. What we had? We had a DDoS, distributed denial of services. What he will do? What distributed denial of services will do? He will block the dummy request originating from unwanted request originating from bots or algorithm or from unwanted resource to reach to your actual server. What we have? We have DDoS here. Distributed denial of services will deny. What it will do? It will block unwanted request. This is my, what this is? This is my unwanted request. It will block this request here. Only legitimate request. This is my legitimate request. Only legitimate request or genuine request are allowed to enter into my end server. So it should not occupy my space here, unwanted space. So otherwise it will decrease my input output per second. This is what we understood. Please take a note here. There is by default firewall. If I say there is a by default firewall here which is configured on a virtual network level, and by default we have virtual network encryption as well. If you enable those virtual network encryption, you can enable those. So this is what we need to understand here in this case. Then what is another circle here? Another circle is I have one virtual network, I have one BNet 01 and I have another BNet 02. This BNet 01 and BNet 02 are not allowed to communicate with each other by default. So resources within this are not allowed to communicate with each other. So if you want them to communicate with each other, you have to set up VPC pairing. If you want to make them communicate with each other, you have to set up a virtual network. I am saying about pairing here. You have to set up the virtual network pairing here. You have to set up BNet pairing here. And another takeaway here is whenever you are creating a resources, those resources will be created within the subnet directly. Anything on virtual network cannot be creating. Pricing for BNet will be, there will not be any pricing for BNet connection, but pricing for data transfer will be whenever you are transferring data from one place to another place, then they will charge you money. Then only they will charge you money. Then where we went into the storage services. Then there we went, sir, one question, route table communicate using only through IGW, internet gateway. You can define the routes, Sundar. You can define the routes with the network. You can define the routes with IGW also. And here we will have invalid this. Here what we have invalid routing here. Then what I am saying, next thing is we understood about the storage. We have a storage here. One type of storage. What we have? We have one type of storage. That storage is nothing but, we have one type of storage that is nothing but disk storage. That disk is attached with our VM. Apart from this, we have a storage account. Under this storage account, we are going to manage, or we are managing, or we managed different type of storage. So these four different type of storage are nothing but, first one is blob storage, binary large object storage. Second one is nothing but file share. Second one is nothing but a file share type. Third one is nothing but a table type. And fourth one is nothing but a queue type. To queue our messages we are going to use. Blob is nothing but binary large object we are going to save. File share is nothing but file type of data. Table is nothing but NoSQL database. Please remember, don't create a table of SQLs. NoSQL tables we are going to create. Because in non-relational databases, your tabular form data, because data will be saved in a tabular form entirely. So that tables we can save here. Queues for message queue. But please remember how you can give access to the external user for this. For storage account, you can define SAS. This is a secured way of giving a access. Shared access signature. So blob storage is nothing but a trash for your storage. Any type of data you can store here. This is very low budget storage, but for infrequent data access type. Then where we went into? We went into the DB service. Then what we went into? We went into the DB service. What I said there? I said there, what I said in DB services, I said in database services here. So we no need on-premises data infrastructure to configure our data. Basically, DB services will provide integration with on-premises. What we have? We have integration with on-premises and cloud services. What we have? We have a cloud database, cloud DB, and by using that cloud DB, we have integration with on-premises and cloud services as well. By default, we have. And here, what we have? We have Azure SQL, right? What we have under DB services, we need to understand we have Azure SQL. What Azure SQL will be used? Single server, single database. What we have? Single server, single database. If you have a single server, single database, so in this case, you are going to use NoSQL, and this is for what? You are going to use the Azure SQL, and this is for a relational database. Please take a note. This is for a relational DB, right? Another option what we had? We have Elastic Pool here. What we have? We have Elastic Pool here. What we can do? We have Elastic Pool here. We can use Elastic Pool here. Elastic Pool is nothing but multiple database, right? What we have? We have a multiple DB under where? Multiple DB under single server, right? But I will not recommend this for a high-end resources because there will be many database things which will be created. So this is what, right? This is what. So then after this, what we need to understand here, this is what we understood. Then after this, what we need to understand another thing here. So why we need to use, now another question, my another question is why we need a DB service. My another question is why we need DB services from the cloud, because DB services will provide inbuilt security, of course multi-factor authentication as well, secure protocol, secure way of communicating to your DB. Another one is SLA is by default here, security is by default here, disaster recovery is by default here, backup is by default here. And why we need storage here? We need storage because storage services will provide us to store our information in a very budgeted price or very less price. It will provide us to store many things on a budgeted price or a very less price. So this is what we need to understand here, right? Then where we jumped into? We jumped into the containers. Then what? No, before containers, we went into the PaaS, platform as a services. Then what I discussed about the app services. Under app services, what is app services? App services nothing but a platform or infrastructure as a, now platform as a service platform to deploy our application to the end user. If you are not looking for what I said, infrastructure, if you don't want infrastructure here, so what you can consider? You can consider jumping to PaaS services. PaaS services will by default allow platform to deploy your application to the end environment. What positive thing you have? Positive thing, by default it will what it will allow? It will allow DB integration. What I am saying, by default it will allow integration with the DB service. By default it will allow integration with the DB services. Then my page is over. Then what about other things? Other things is nothing but now I am going to the containers. So what other things we discussed? We discussed about the containers as well, right? So now what we discussed here, we discussed about the containers. Why containers, right? Now you people should be master, right? Why containers? So what we discussed about the container services provided by cloud. Container will help us to package our application in a very customized or certain way. What I have application here, and this application we can package where? This application we can package within the container. Why container came into the picture? Because architect shifted from monolithic to microservices. What is monolithic? Monolithic is nothing but a single packet of application, single point of failure. Microservices is nothing but the entire application architect is divided into small services. So for those small services, we can create a containers. Basically, container will provide very independent or absolute environment for our application to run. What container services cloud is providing? Very important service name is nothing but ACR. Another one, what we understood, Kubernetes, right? What we understood, Kubernetes cluster, or can I call it AKS? This is very powerful. And third one was a container instance. So we understood why we can use and where we can use these three services provided on technology called containers. By whom? By cloud, sir, by cloud, right? That's it. Then where we went? Then we went into the DevOps, right? Then we went into the DevOps. Any question here? If you want me to unmute, I will unmute. Then I will go to the DevOps. Please understand this is the flow what we did, right? Of course, there are many things here left. Of course, not possible, but I want to create one flow. You can understand what we did, right? Those who are joining session every day. So this is what. Yes, any question here? Yeah. Any question? Mr. Chavan, any question? Binay, Riaz, others? Right? Yes. But what? Yeah, please share the image after class. No, Sharad, I will not share. Right? I am asking about the question. You're talking about image. Question. Don't worry. This is for you people. I'll share this image. Understand? Container instances for small scale application. Suppose you have microservices, you created an application by using microservices. You can use the container instances for small scale application. Why I said, why we will not use Kubernetes cluster? Because Kubernetes cluster is very, very high end, means it's for a very large scale application, because costing for cluster will be very high. Understood? So this is what. Any question here? Nobody is saying something, right? We discussed this, right? Or any suggestion here, anything, right? So this is what I'm saying, right? Okay. What about others? Yeah. BM can be your agent, and BM can be a deployment platform. You can deploy application as well. BM in DevOps, BM is agent, first thing. Second thing is BM can be your deployment platform. You can deploy application into BM as well, right? But this is the old way of doing. Now we are not using, no longer much using BM, right? This is what, yeah. Points on IGW and route tables, routing table. IGW and route table, as I said, IGW is inbuilt here. Internet gateway is built here. Basically, internet gateway is nothing but a gatekeeper between. Internet gateway is nothing but a gateway between a network and a, right? Network and a user. Internet gateway we have inbuilt here. That's basically routing table. Route table we have inbuilt here, but we have a routing method that is very vast. Point on ACR, Azure Container Registry, just the registry and ACI, please. When should we use? ACR is nothing but a container registry, Nikhil, right? If I'm talking about a container registry, what is ACI? ACI is nothing but Azure Container Interface, actually. This is the interface provided by whom? Provided to run the containerized application. Fair enough. IGW is default. It's inbuilt. Please remember, right? Not required. Route table customized are required. Yes. IGW. This is route customized are required. Customization are required. So now let me go to another thing here. Right? I am feeling you people no need this. I think. Right? You people are comfortable. I am feeling. Because I am getting very cold response actually. I am feeling cold because it's raining outside. Right? I paid 100 rupees for auto to come here. Right? I'm working on Saturday. Right? I think no need. I'm feeling very cold actually. You people are very cool now. So what I'm saying, so now here, what I'm saying, please take a note here. Then I'm going to the DevOps. Now here, why we need, please remember here. Now here, I need containers if my structure is, now here, what I need containers? I need container if my package process is image. If my package process is image, I need these services because I need to expose my server securely. See, end thing is coming from here. Here. See what I'm talking? I said about this thing here as of now. This thing here I said. Now, if your end user application need data, we will provide data. If we need server, we will provide server. And for all of them, we need communication. We need networking. Right? So this is what we need to understand. Then let's understand about the DevOps. Again, same old story here in DevOps. What is the first thing? My target is to create a application interface environment. What is my target? My target is to create an application here. As I need to create this application here, straight away your one best friend will come into the picture, right? They will be your high-end competitor as soon as you will enter into the office. What I'm saying, your best friend is nothing but a developer will enter into the picture. Please don't consider I am putting a business team as well, because from business team what we need, from business team we need requirement. Actually what they will do, they will give us documentation. Please remember, the final documentation we will get docs, clients docs we will get from the business team, and this business team will pass this documentation to the developer team. Developer team will write the code only for a front end and back end. Take a note here, they will write the code for a front end and back end. Back end code will be written by them. There will be different front end language, there will be different back end language, and by writing those front end and back end language code, we are going to get final code changes, and that final code changes can be in Azure repos or can be in a Git and GitHub. So it can be in a Git and GitHub, and or it can be in your Azure repos. We are a boss to decide here where it can go. So Azure repos can be, right? So right, what I'm saying, this is called version control system, or this is called source code management, or this is called source code management or version control system. Here we are going to get the final code changes. After getting the final code changes from here, then we are going to build one pipeline. We are going to build one pipeline. What we are going to do? We are going to build one pipeline. This pipeline will process two tasks. First one is CI, continuous integration, and second one is continuous delivery. In continuous integration section, we are going to create a package of application. We are going to create a package of application here, and that same package of application we need to deliver to the end user. The same package of application you need to deliver to the end user, but we have a very specific task, this artifact. What is the name of this? We are going to create a package. This package is nothing but artifact. Please remember, this package of application we are going to create, and the same package of application we need to deliver on where? On a infrastructure. As I said, we need to put this on a infrastructure here. We need to put this on a infrastructure, right? We can use PaaS services provided by cloud, or we can create our infrastructure, and that infrastructure should be compatible enough to run your application. Example of artifact, sir, whenever you are downloading game, what you are downloading? You are downloading a package of application. That package of application from the web, right? That is called artifact. Whenever you are downloading something, you are downloading from internet, right? Chrome, whatever you are downloading, right? That is nothing but package of application written by front end back end language. And that package of application you are installing on which environment? On a window environment in our laptops, right? So this is what paint. What is a paint? Paint is example of my application. But this packet of application is where? It's inbuilt here. But actually this packet of application will be in my Microsoft Store. In my Microsoft Store, whatever you are getting in Play Stores, Play Store, what those are? Package of your application. What those are? Those are package of application. For what you have created those package of application? To run on a mobile environment. What you have created? Can I say those are mobile application? Basically mobile application package, artifact, right? So this is what you have to understand. Then what I'm saying, in CD process, in CI and CD process, continuous integration and continuous delivery process. And if I say about pipeline here, if I say something about pipeline here, in pipeline we need to consider certain thing. Before that I need to increase the page size. This became too lengthy actually. And are you allowed to download this? If you can download, I will be very happy. Keep this. Don't share with share with your ex. Okay, Sharad. Don't share with your ex schoolmates. Are you allowed to download this? Online, are you allowed to download this? Yeah, okay. So then it's okay. Okay, download this, please. Okay, keep this in your desktop. Read, listen. This is a workflow. Then what I'm saying, we have a pipeline. To create the pipeline, what I need underline server. To create the pipeline, what I need underline server. If I need to create the pipeline, I need underline server. Here it's called agent. And this agent is of two type, as I knows. Microsoft hosted one, right? We have two type of agent, Microsoft hosted one and a self hosted one as well. What I have Microsoft hosted agent, self hosted agent as well. Microsoft hosted agent will be managed by Microsoft, self hosted agent will be managed by self hosted agent. When to use Microsoft hosted agent, we need to check what are the software we have on Microsoft hosted agent. If we have required dependencies installed on Microsoft hosted agent, we will go to the Microsoft hosted agent. Otherwise, we will go to the self-hosted agent. Self-hosted agent will enable, what self-hosted agent will do? Self-hosted agent will enable us customization. If you want to customize your agent in your way, you can customize that. You can customize that agent in your own way. Very, very important one here, right? So this is what we need to understand. Then what I'm doing here, then we shifted to the Docker. Then we shifted to the Docker. Let me write another color now. Then where we went into? We went into the Docker here. Then in Docker, what we need to understand, but I missed Git and GitHub, right? Git and GitHub is nothing but simple, right? Version control system. Then what we need to understand here, in this, what we need to understand, here, see, what are the takeaways? Okay. What I'm saying important point. What I'm saying, important. So what I'm saying, important point in pipeline. What I'm saying, important pipe in pipeline creation. What is the important point? First one is agent. First one is agent here. Of course, second one is you can create by using YAML or by using classic editor. So you should be ready for both. You should be ready for both. Then third point will be a selecting a right template. What I am saying, selecting a right template here for right task. Then agent, please remember agent. What I am saying, in agent we should have what should have required dependencies. In agent we should have required dependencies, right? Then apart from this, we need what we need required infrastructure. What we need required infrastructure. By using required infrastructure, we can configure our pipeline in a systematical way. Then again, I am going where I am going now. Next process, what I am doing, next process, we are going to the old story called Docker. What I am saying in Docker, what is Docker here? Docker is not a medicine here. Docker is nothing but your containerization. What I am saying, Docker works on a technology called containers. Actual logic behind this is containers. Container will provide us, will help us to package the application. It will provide very absolute independent environment to run the application, and container will provide us another additional thing I am giving, that is nothing but OS level virtualization here. OS level virtualization here. OS level virtualization here. Container will provide OS level virtualization. Another takeaway of container is container by default. What I am saying, container, I am using European English. Container no have, in place of don't have, I am writing no have, right? What we don't know have here, what we know have, we don't have OS and hardware. Basically, what I am saying, right? Will take from host, right? Right? Okay, so host will be shared on all containers. Okay, host will share shared by all containers. Okay, so who will enable this? Docker engine will enable this. Okay, who will enable this? Docker engine will enable this. If you sit with me for 6 or 7 hours, I'll give this in more detail, right? 6 or 7 hours, if you will sit me continuously, you have to sit, because you cannot break this, right? So this is what I am saying. This is what. Then in Docker, what we need to understand? In Docker, what we have certain, of course, basic command lines we need to understand. And there was another concept called port mapping. Why we need port mapping? So we need to expose our containerized application outside the world. For that, we need port mapping, because from mapping through IP is not possible. We cannot map through IP. Why? Because the restriction of IP, as soon as my container will die, my IP will change. As my IP will change, this port mapping will help me to map my port, that we are running inside the container or application, to outside world that we are running within the container. Then we have networking concept. What we had? We had networking concept. Why we need networking here? So networking will provide customized interface for your container to run. Then we had volume. We need to map the storage. We need to use the volume mapping, because we don't have inbuilt storage. For that, we need to process our data outside this. Then what we have? Then we have next process. You need to understand what we have. We have a Docker file. From the Docker file, there will be an image. We have a Docker file. From the Docker file, there will be an image. This image will be pushed into the registry, and this registry will be a public or private type. Public or private type. And then this registry we are going to run, and from this registry we are going to run, and of course from this registry we are going to take the image, and we are going to run the container. It takes a lot of energy to speak continuously. So this is what, please take advantage of this. It's not easy to talk continuously for approximately 1.5 hours. So what I'm saying, we have a Docker file. So people, sir, we are paying you. It's not money always, right? I think you can understand, you are educated people. So what I'm saying here, Docker file, image, registry, containers, right? What we have? Docker file, image, registry, containers, right? So this is what we need to understand. This is a workflow here. Finally, we are going to get the container. But if I say the registry here, registry we can use Azure right? Very rarely we need those. So we can use ACR, we can use Docker Hub. This is what we need to understand from here. My internet is unstable. Okay, this is what we need to understand, right? Yeah. So this is what we need to understand here. So then what we need to do here after this, then what we need to do, then we understood about another medicine called Kubernetes. What Kubernetes will do? Kubernetes will provide orchestration. Now here what I am saying about another tool here. Now I am adding another tool in our bucket, and that tool is nothing but our Kubernetes. If I'm talking about another tool called Kubernetes, now what Kubernetes will do? Now if I say about Kubernetes, now this Kubernetes is nothing but a orchestration tool. If I'm talking about Kubernetes here, I am talking about Kubernetes. Kubernetes is nothing but orchestration tool, spelling error. Orchestration tool. Basically, it will help us to manage the containers. And Kubernetes will work in the form of master and worker node. What we have? We have master node and we have a worker node. Master node will have a master node processes, worker node will have a worker node processes. What are the master node processes? But both are, this is nothing but orchestration tool, and this will work in the form of a cluster. If I say cluster is a combination of what? Cluster is a combination of a master node and a worker node. From this session, one thing will be very, very clear, right? You will put more effort because you will feel you are not there yet. So I want you people to feel you are not yet there. Okay, you need to put more effort. What I'm saying, master node will have a master node processes, worker node will have a worker node processes. Master node processes are API server, right? Scheduler, controller, scheduler, then we will have a controller, and apart from controller we have etcd, etc. Right? These are nothing but these are my master node processes. And if I say worker node processes, under worker node processes, what we have? We have kubeproxy, kubelet, and pod. Pod is nothing but abstraction over container. Within the pod we have, right? Within the pod we have a containerized application running, but pod is smallest unit in Kubernetes. Another thing you need to understand, CRI, container runtime interface, right? Container runtime interface we have here. So this is what we need to understand here. Of course, API server will validate and authenticate, scheduler will schedule the pod, controller will control entire operation within the cluster, etcd will store value in the form of key value pair, kubeproxy will handle all networking, kubelet will help. What kubelet will do? Kubelet will manage the pod. Pod is nothing but abstraction over container. Within the pod we can have more than one container, and there should be only one helper container. We cannot have, there should be only one main application container. We cannot have more than one container within the pod. And pod will have a unique IP as soon as pod dies, because pod are ephemeral. As pod ephemerality, because of lack of resources, networking is not proper, because of that pod will die. As pod will die here, this pod has to be replaced immediately, and it will be replaced immediately, but your IP will change for the pod. Rest all resources, whatever it is, whatever it was, it will be created same as it is. So this is what we need to understand. Then again I am saying, whenever we are going to create the pod, if I'm saying I'm going to create the pod, if I am willing to create the pod here, this pod I am going to create from the deployment. Directly I will never ever create the pod. What I'm saying, directly I will never ever create the pod. If I'll say this is my pod here, what I'll say, this is my pod here, this pod I am going to create by using deployment. I will have a deployment to create the pod, because deployment will create the replica set, and replica set will manage me to help me to manage the pod. So what we have, I have a deployment here. Take a node here. We need to understand what we have. We have deployment. We have what we have deployment here, and within deployment we have replica set. Within replica set we have a pod here. So this is the flow. So this is the flow here. This is what we need to understand here. Then we need to understand about the volume here, right? If I say about the volume here, here we have what we have what volume here? I missed volume here, right? So here we have volume as well, right? Volume. Okay, I didn't meant it to very specific, but we have three type of volume: anonymous volume, named volume, and host volume. But here what we have? Here we have PV, persistence volume claim, and storage class. What we have? Persistence volume claim, and storage class. Then we need to understand another thing called namespace, virtual subcluster within the cluster. Then we need to understand virtual subcluster within the cluster, right? Now here it was talking about Helm, right? What is a Helm is a package manager, basically package manager. What is a package manager for Ubuntu? apt-get, right? What is a package manager here? Helm. Understand? So then what I'm saying here, Then what I'm saying here, apart from this, we understood how to do a deployment by using AKS, right? Azure Kubernetes services here, and how to enable external services to the external world. So how to enable external services to the, this is what, right? So how you are going to troubleshoot? So there are many, as I said so many time, how you are going to troubleshoot, right? First, what you have to do, please remember, you need to consider which environment. Forget about pod. Forget about pod here, right? You are going with the Google answer. Forget about pod. If there is any problem in Kubernetes, how you are going to solve? Right? Forget about pod, because under Kubernetes, all components, how you are going to solve? Please remember, this will be considering, this will be connecting to the monitoring. Kubernetes cluster or Kubernetes is connected to the monitoring here. So you are going to monitor, or you are going to supervise what is actual problem there. According to that, you are going to troubleshoot. You are going to monitor the resources. After monitoring, you are going to troubleshoot there. Of course, if I'm talking about pods and all, for pods and container, there will be logs. From there you can understand, and there will be, as I showed during sessions, right, what he was giving me some yellow type, right? There he will give me a type of error. To the type of error, we are going to solve this. What we are going to do, we are going to solve this. Then we started with what? Then we started with the Terraform here, right? This I'll continue on Monday. This I will continue on Monday. Try to understand, try to get a workflow here. So what I said, try to get a workflow here. What I'm saying, I'm saying a workflow for what? What is your batch? 7:30, right? 7:30 a.m. and I'll upload this, and you can read this, and please listen what I said here, right? And I want you people to listen. Those whoever have recording, please listen what I said. Okay? It's very, very important here, right? If you ask somebody who have proper knowledge of DevOps, ask him to talk like this. Understand? Then you will understand how good it will be. Listen this. I want you people to listen this, not to judge. Listen this. If you listen this, it will be. And if you're not following day-to-day session, you will not understand what I said. Then you will be confused. You will feel like I am saying world is very good, each and everything will be very good, sit and sleep. Right? You will feel like this. Okay? I will email you architect. Please let me feedback. It's based on architect of my prompts. After viewing, please give me a feedback. Sundar, why you are sending architect of your office? You are architect or what? Cloud is mine. Okay? Send me, share me, Sundar. Okay? Share me. Okay? Yeah, cloud is mine means I'm confused. Okay, share me, no problem. I'm confused what you're asking. Okay, I will email you architect. Please let me know feedback. Please cloud face for my PM structure. Okay, okay, no problem. You can share. Yeah, you can send. Yeah, appreciate your effort of talking continued for right. Very important. Thank you, Riaz. Thank you very much. Right. Thank you for this. Right. We are using on-prem. I want to know how to move to the cloud. Migration.